Hi, I'm Dr. Gary Betticher, and welcome to Software Construction. At this point, I want to go over the Unit 1 notes, which is the Introduction to Software Construction, and an overview of UML. And all the unit notes follow the same pattern here, so I'll talk about what to look for in the notes and how you can use it to best learn as much as you can. So typically it starts off with goals, and in this case, this unit introduces software construction, discusses the merits of studying software construction, course goals are identified, and a general overview of UML is presented. Next, I follow with objectives. And you'll see, for example, by the end of this week or these notes, you'll be able to identify course goals, explain what is UML, identify the benefits of using UML, identify different components of UML, and then there's a series of terminology and concepts. So for this unit, it includes Object Management Group, OMG, Static or Structural View, which you don't know yet, Dynamic Behavioral View, and components of UML. And as you go through the units, come back to these objectives and say, can you now identify the course goals? Can you now explain what is UML? Can you now identify the benefits of using UML and so forth? So the objectives will help you figure out whether you've learned what you need to learn from this particular unit. And then below I have an outline of what we're going to be discussing for this particular unit. Okay, let's get involved here. Well, as you know, the title of the class is Software Construction. And software construction may mean different things to different people. So let's figure out what is software construction. Well, constructing software involves all phases of the software lifecycle, including requirements, analysis, design, coding, testing, and maintenance. And for IEEE, Software Engineering Body of Knowledge, version 3, they say software construction refers to detailed creation of working, meaningful software through a combination of coding, verification, unit testing, integration testing, and debugging. Boy, that's a mouthful. And we're going to be focused, in terms of software construction, on the software design phase and the coding phase. And one of the things we'll be using is called UML, Unified Modeling Language. And not only will you learn different components of the Unified Modeling Language, but I've also say, well, how does this component tie in with the software lifecycle phases? So, for example, you might have class diagrams that are used prior to doing coding. And so I want you to not only understand the different components, but how they tie in with the whole software lifecycle. Well, why do we study software construction? Well, there's a consulting group called the Gartner Group, and they project like a 6.4% growth in software in 2013. Total industries revenues approach about $300 billion. That's with billion. They bring a 3-year growth rate for software industry of about 6.8%, and they anticipate the future growth to be $360 billion by 2016. So a lot of growth trends going on. And software construction is a major portion of software development, and depending upon the project, it's estimated that 30 to 75% of software effort resides in software construction. And it's really the core of software development. So previous lifecycle phases, requirements, analysis are done in order to effectively construct software. And later phases, lifecycle phases, are done as a consequence. Now here's an interesting little research. Sackman shows that the productivity between programmers can vary by a factor of 10x. Robert Glass, who's done consulting and he writes a lot of papers in software engineering, says the programs can vary by 28 times better than the worst programmers. Now, obviously, if you're one of the better programmers and you're 28 times better or 10 times better, you're going to get paid a lot more money. Also, if you're one of the worst programmers and there's a downturn, you're going to be one of the first persons fired. So in order to help improve you and be more productive, I highly recommend you learn as much as you can in this class so that you're one of the more productive people wherever you happen to work in the future. And software is the primary deliverable that customers pay attention to. It makes sense to invest heavily in the software construction activities. Well, here are the course goals, and in one sentence, the course goal is to engineer better sustainable code with fewer bugs. Repeat after me. Not that I can hear you. Engineer better sustainable code with fewer bugs. Now say it really loud, really loud, so I can maybe hear you even though I might be 100 miles away. Engineer better sustainable code with fewer bugs. Don't know if you heard me. So by better we mean that the code is robust, well organized, and readable. Sustainable means that the code, we do not want it to be brittle. So you want the code that if you make modifications is not going to break the software, and you design it so it can be enhanced in the future. Fewer bugs, obviously we want the code correct, and we want to write what's called defensive code. Defensive code means the following. Let's say you want a person to enter in number of years experience. Let's say instead of the number 7 they type in SEVEN. Well, you want your program to handle the case where it's non-numeric data, and that's an example of defensive code. You don't want it to crash at that point. And we want to also optimize the code in terms of quality productivity, and we want to be critical of tools and methodologies. We want to ask, so for example, if you see a tool, what is the learning curve to learn that tool? And what value does that tool add? Would I be better not using a tool? And another thing, what context would it be worthwhile to use a tool? So for example, in extreme programming, you might not want to use as many formal tools as if you were with a large company, software development company. Well, the unified modeling language, we're going to refer to version 2.5. And there's different versions that have been created, but the latest one that I found was 2.5. And the details for the latest version are here. And there's a group called OMG, Object Management Group, and they're responsible for developing and maintaining UML standards. So here's a link to the UML. And here is the object management group that develops, maintains OMG, or develops, maintain UML standards. Okay, why do we study UML? Well, for several reasons. One, UML is a good refresher. If you work on a project, and what happens in industry, you work on a project, you get pulled off, you might get on a project 6 months to a couple of years later. So it's a good refresher, plus you could see what changes have happened since the last time you worked on the project. It's also a good orientation in the sense that if you're a new developer with a project or with a company, the UML would help you get up to speed relatively quickly to see what's going on. UML is a good communication tool, and so if you have a client, you can explain a lot of abstract information to the client to help them understand what's going on. Martin Fowler calls this a sketch, and it's also good for legacy documentation. Having that, will maintain legacy documentation. You can maintaining UML documents promotes project sustainability. It's language independent, so it's not depending on Java or C#. And you can explain large, complex systems. Well, I'm going to take a break here and come back, and we'll continue with the Unit 1 notes.